Hi, y'all. In this lecture or video, we're going to briefly go through Kirchoff's rules, which are a tool to help us analyze circuits. They're maybe a little bit more complicated than just a simple series or simple parallel circuit. So I will get my PowerPoint up here. There we are. And get rid of my face. And we'll take a look at this. Okay. So Kirchoff's rules, there's two of them. They state that, well, the first one is the junction rule. It says that the total current that goes into a junction equals the total current coming out of a junction. And that makes sense, and it's something that we've seen before in lab. When we looked at what happened when we had current come into maybe a couple of wires, a couple different pathways that it could split off of. And then we said, oh, you know, when it splits up, it's got to equal, you know, how much current was coming in. The second rule is the loop rule. And the loop rule says that as we work our way around the battery or around the circuit, coming from the battery and then going through maybe one resistor and another resistor and so on and so forth, and then returning back to the battery, that all the voltages that are present around that loop end up adding up to zero. In other words, if we start from the battery, we start out with some voltage, and then as we work our way around a closed loop, that voltage gets used up until there's no voltage left. All right, so here's the junction rule. Again, this says that the total current that comes into a junction is equal to the total current going out of a junction. Whoops. Okay. There we go. And so I'm just going to try to draw here maybe a circuit. And I've got three resistors, resistor 1, resistor 2, resistor 3. Okay, and I can maybe picture some current coming from here. And this is the current going through resistor 1. And then when that current gets to this junction right here, it's going to split. Some of that current is going to go through the line that has resistor 2 on it, and some of that is going to go down the line that has resistor 3 on it. Right. Now, the total current that's coming out of that battery, that's going through that battery, is the same as the current that goes through resistor 1. Now, if we take a look at maybe this junction here, let's call this junction A. We take a look at what happens at junction A. Well, the current coming into the junction is equal to the total current coming out of the junction. Okay, so there's one example of Kirchoff's junction rule. We could also take a look at maybe this area right here, and we can call this B. Okay. And if we think about maybe the current coming in here, we've got I3 there, and then we've got, well, we can call this either I total or I1, whichever one we want, because I total and I1 are the exact same thing. And then if we analyze junction B, what we see here is that, again, the current coming in to the junction is equal to the current coming out of the junction. And again, we can call this I1 or IT. I'll just, I guess, call it I1. All right, there we go. Okay, the next rule is the loop rule, and this rule says that as I work my way around a loop in the circuit, that the voltages are going to sum to zero. Let me lost track of what I was doing there. Let me go here and draw in a resistor, draw in a resistor there, a resistor there. So this is the same circuit that we had on the last one. All right. So let's take a look here. I'll draw in blue maybe. If I start from this battery and I work my way around, say, this loop that I'm drawing right there, where I'm going through resistor 1 and then through resistor 2 and then back to the battery. Let's call this loop A, I guess. And I can look at loop A, and how my voltages are going to add up. Well, I'm starting out at the battery, so I'm starting out with some initial voltage. And then as I work my way around, well, some of that voltage gets used up across resistor 1, or I have a voltage drop across resistor 1. Some of that voltage gets used up across resistor 2. Resistor 3 isn't in this particular loop. I'm not going through resistor 3. Okay, so I've gone through resistor 2, and then there's nothing else that I go through other than wires, and we'll assume that the resistance there is negligible. But now my total voltage there, as I work my way around the loop, is going to sum to 0. I can use Ohm's law, which Ohm's law states that voltage is equal to current times resistance. To write out another expression, but this one right here is really Kirchoff's junction, or excuse me, loop rule as applied to loop A. All right, let's make another loop. We'll start out again at the battery and work our way through resistor 1, and then maybe through resistor 3, and then back to the battery. And we can call this loop B maybe. Now for loop B, again, what happens? I start out at the battery, I go through resistor 1, and this time I'm going through resistor 3 as I work my way around the loop. And then there's nothing else in the loop as I work my way back to the battery all the way around. So that's going to total to 0. And that would be my Kirchoff's loop rule for loop B. And again, I could pull out Ohm's law and apply it as I like. So maybe I can do I total, R total, minus I1, R1, minus I3, R3, and that's going to total to 0. Notice I'm being really careful with the subscripts there and retaining all the subscripts as I go through. All right, this does it for this one, guys. I will be coming right back with some examples using these tools.